All right, so now I'm going to be solving question 2 from chapter 26. And this question is related to chapter 25, but here we have a more complex circuit. We have a couple of resistors with a couple of batteries, and then we have loops, right? So first, what we need to note, what we need to do is to determine the direction of the current, and the value of the currents and direction are already given. So it's not that hard. This question is not going to be as difficult as it might seem. So first we see that at this point right here, we have a current 3.0 amperes going in that direction. And then once it gets to the junction is going to divide into this current and the 1.2 current. So that's simple. In order to find that current, we just know that this part coming out and these two parts coming out need to be equal to the one going in, right? So we can say that the 1.2 is going to be equal to the initial minus this one right here. So the current I is going to be 1.8 amperes, 1.8. So, okay, that's great. So now how do we find the voltages, or, the values for the batteries? So like that, we need to be able to use a loop rule. And we can, in this case, I started at this point, but it could be any random point of the circuit. I started with this point and I know that the current is flowing in this direction, right? So what I'm gonna do is, if I go in this direction, I know I'm going from an area of higher to lower potential. So I'm losing some of that. So this is gonna be negative. Then I encounter E1 or V1, but it's going from an area of low to high potential. So I need to add them. And then if I go and I counter E2, V2, then that is going to be as well, it's going to be a sum, the sum of them, because you're adding them because you're going from a lower to a higher potential. Now you get to a point and then it has to be equal to 0. But then if we look at the overall circuit, like the one outside the outer circuit, and we start from this point, in this case, it start from this one, so we get a positive. We start from here, we have gain of potential. We're gaining potential, so we start with V2. We continue, we don't have any resistance until this side right here, in which the we lose, and this is also going to be put in there, in which this is going to be the current times the resistance, so it will be 1.2 times the 23 ohms, right? So we can use this to find VU2, which is 27.6. And then if we go ahead and we find the other one, VU1, by using this equation, then we get that VE1 is 3.0 volts, right? And that will be the answer. So then again, we need to use the loop rule. We need to look at the currents, how they're splitting up at a junction, being able to find the current, and then from the current, find the voltage, all right?